It should. Yeah.
All right. So let's start. So again, welcome everyone. Good morning. So we'll start today the day 2 of our Gen AI agentic course. And before doing that, let's quickly do the recap of what we did yesterday to get an idea where we all stand in terms of understanding. Let me share my screen. So once you're seeing my screen, please let me know. Okay. So yesterday we just talked about things around AI, Gen AI, and how industry is moving towards that, and globally what impact it would bring to the society, but also to our jobs. And then we all understand its impact. And then, of course, uh, today what we want to do is basically go through a bit more detail to understand to the level that we can also be part of this journey of the Gen AI wave. And then we can also start to implement things that we can contribute in our existing job, and also if needed, maybe do the projects around Gen AI ourselves, or maybe also do, let's just switch career in Gen AI to other companies, or maybe start your own startup. So that's the idea that we are following. So today what we will do is we will do some quick learnings which are for important concepts, and then we will spend most of the time in building AI agents. And we don't need any programming language knowledge as of today for building the agents. So that's my goal for today. And of course, if there will be questions, doubts, we will take along. Before we get started, anyone wants to share anything or has any questions, doubts? Okay. One thing I will repeat, please make this session interactive, because today, if you don't ask, trust me, you will have doubts and questions which will annoy you in future, because this is the future, what we are learning today. So, so make sure you ask questions if there are doubts. So let's get started then. So this was the course curriculum which we will be going through, but there are many other topics in this. Like each of them is a, let's say, the super topic, but there will be subtopics within them. So we understood why learn Gen AI, because we know disruption is real, and then uh, powerful automation plugins are getting developed by different other Gen AI big players like Anthropic and Google and OpenAI. The companies that we work today with, they have clients, and those clients are changing the business model. They are moving away from the regular hourly billing mode of per headcount resource to output based delivery, which is already happening. It has started already in US and Europe. Companies are pushing the Indian IT companies to go away from hourly model to output based delivery, which means the Indian IT companies or any IT services company will try to push that onto employees, because if hourly billing model is stopped, then it will be like clients will ask the service provider, the vendor companies to provide certain amount of output. Doesn't matter how many employees they want to keep or how many AI agents they want to use. So this is the main point, because of which there will be a lot of job losses that will be happening, and this has started this year itself. When the contracts are getting renewed, big companies are already doing this. So the effect of this will be coming, let's say, in this appraisal cycle to some extent, but 27, the next year appraisal cycle, you will see a huge impact of this. And then billions of dollars is getting invested in the existing infrastructure of the models that is being built by the US companies, Chinese companies. So it is only growing, the amount of money it is getting into those inventions and the research. So it's every hour that these discoveries or these new models or new agents or maybe something else is going to come tomorrow. Because if the money goes there, of course, people are motivated to make more inventions and discoveries. So it's not going to stop. And we all are also aware that already the World Economic Forum has done some projections around job losses and then, of course, job opportunities. So we want to be here in the job opportunities area. And traditional IT services, BPO jobs will also disappear fast. And slowly, the IT services companies will start to report losses in their quarterly earnings because of this that is going to happen. So that's where they will try to compensate the loss by reducing the headcount of the people. But by the time that happens, it will be already 6 to 9 months from now, and that at that time people will not know why they are firing. It will be in the mainstream news, and at that time people will try to look for reason. But reason is now the contract negotiations that are happening now. So no matter which company you're working, this is what it is going to happen. And what will be the expectation? A company will start to expect something from you because they will not fire you directly. They will basically ask you, can you do this for us? No matter which role you are. If you're in management roles, let's say 16, 20 years of experience, they will ask you to lead teams and try to deliver same output or more output with the lesser people and using agentic AI solutions, Gen AI solutions, and they will ask you to do that, which means you are in a very crucial position in management roles. You will not be only now just managers, so you have to become technical managers who also knows in and out of these technologies and knows how to increase the revenue or increase the productivity of your team. Otherwise, those high paid roles will cease to exist. Same way for developers or for let's say other people or people business analysts, it won't be just writing prompts and getting answers and copy pasting. Instead, you will be asked to create complex workflows automation pipelines so that your productivity increases in your day-to-day job. And for juniors or media developer, no more just coding. Coding will be done by agents. I will also show you today. Instead, coding is something agents will do. What you have to do is make sure the architecture, the current, what the job which the solution architects or designers are doing, you are able to do those kind of jobs, or you are able to also do some kind of business analysis work, or you are able to talk to clients directly and get involved in big meetings. And then finally, of course, the code written by the agents and those things you should be able to cross verify and then let it get deployed to production. That will be your job. Coding will cease to exist in, let's say, a year's time from now. If you're just coding, the companies don't need you. It is going to be a hard truth. Similarly, seniors who are currently now in the senior role, they will be again asked to come up with ideas to increase the revenue of the company, increase the productivity of the company, and maybe come up with some innovative ideas or products or solutions and do multi-skill work. If somebody is just doing architecture now, they will be also asked to do ML ops or DevOps roles or maybe go into stakeholder management. The product owner job might be not existing anymore. Instead, these senior technical leads today will be asked to also do product owner roles and also the senior leads roles. So we will see a lot of roles getting merged and some of the roles getting disappeared. And that is the reason, if you see, many of the big tech companies, even non-tech companies like the GCCs, JP Morgan, and they have already given their employees access to GitHub Copilot or Claude inside their company. And they have already done this in 2024-25. But then employees are not utilizing it. But companies have given you that, which means they already found a way to fire you in future. They will tell you, we already gave you opportunity, we already gave you the tools, we already gave the learning portals like Udemy, Pluralsight, all these things to reskill. We were also asking you to set in your goals and reskill, but you did not do that, and hence we don't want your service. They can say that easily, because with Copilot installed in your company or cloud, they also track. If you are not aware, every prompt that you write, everything that you do is being tracked in by the Copilot metrics, and it goes to management, and they are basically tracking this to they even know which employee or which person is using it how much, and also to for what purposes, and they can show this data while firing. So all this is part of a bigger play that is going to come in very near future. So now what are the career options? So as I said, coding will cease to exist, but it doesn't mean the coding, the logical reasoning or the writing the blocks of code across different microservices, front end, back end layers, or in each component, the different best practices, that will not go waste. That will be used, because even if the agents or this code will be written by an intelligent system, but before going to production, the final check will be done by somebody like you, but then not like a junior, but a senior who understands the code which is written by this expert system. And some of the career option which will still, at least what I'm reading and I can see, for the next 3 to 5 years, these roles will definitely exist. Data science jobs will still be coming up. ML engineers, yes. ML ops engineers also. Gen AI agentic developer, these roles will be also coming. There will be more and more job roles for this position. AI architects, AI architects, and these two combined along, and if you have this role along with your existing role, will be giving you a lot of benefit. But there will be a sharp rise in this position, because these can be the people who can also act as a product owner along with the architect, along with they can also code, or they can also design smart systems. You can have your build your own startup. And at this moment, if you see the average salary people are getting is like already 35 LPA in 5 years experience. But they are also getting more if you are in the right company giving interviews. So how to get or switch to AI jobs? So switching jobs will not be that easy anymore. What they will ask is, if you're coming from, let's say if you're switching the job, they will ask you, what do you know about Gen AI, and all the fundamentals and other things they will ask. Then they will ask, what did you do with these technologies in your project? Of course, these are quite new technologies, only 3 years, so you may not have got chance to do something with it. But they will ask you, show me your portfolio. What have you done so far on your own? Have you built some things or real world projects or solved any use cases in your existing job? They will ask you this. Then, so how will you do that? By doing this, right? Solving day-to-day problems at your current job with Gen AI, you can also build a portfolio outside in GitHub that you can showcase to your interviewer when he is asking questions. And then you can also develop agents for getting new businesses or revenue for your existing company. Then, if you do this, you are automatically coming into the limelight. Then develop agents for the SDLC lifecycle phases. You can develop agents for simplifying work or task, or reducing cost, increasing your productivity with the day-to-day ops, infra and release process and incident handling process, because a lot of time goes wasted here. So how can you reduce those, uh, the waste of time, and also the productivity part? How can that be increased? So you can look into these aspects also. This is easy things. Here there is no risk involved of brand image or losing brand image of the company or organization. So these are the easy play which you can do in your current job. Then you should participate in hackathons, events, go and give talks, write LinkedIn posts, stay up to date. This will also help you get attention from the recruiters. Then, of course, certifications. If possible, you should do certifications also around these technologies, especially with Azure Cloud and GenAI or AI, because Azure Cloud is used widely. Of course, it is good, but also it is very cheap compared to other clouds. Hence, You should, if you're planning to do certification, we will talk about it in future. You should focus on Azure Cloud. And then implementing ML ops, if it is not there in your project or the company not allowed, outside you should try to do this ML ops for rack system agents, fine tuning, or maybe building a small LLM model. These are large language models which we see in the industry today, but you can build your own small LLM model from scratch, write the code, write the algorithm, train that model, and then use that model for a specific use case. So this is what you can also focus. But then in nutshell, to get an AI job will not be an easy task as it used to be in 2020, 21, and 22. The switching of jobs was very easy then. Now it will be becoming difficult. But if you are in this thing, doing these things, you will also get a very nice job, but easily able to switch it if you are doing these things. Because this is exactly what company needs for the next 3 to 5 years. And we talked about this pillar of intelligence yesterday also. Like uh, first, it all starts with data. For us also, we started learning in childhood from data, from information around us, from books, from school, from television, from things around us. So all these are information or data, and from there we started learning, and after that we started reasoning, and tried to apply those learning in good and bad form. Uh, and then finally we started to take actions also on our own, whether on certain things we took a decision whether to go that way or this way, or maybe take this decision or that decision. Exactly, this process has been now transferred to machines. This is exactly what we were doing here till now with us. And this process of transfer of this human intelligence to machine did not started now. It's a concept of already uh, in 16th century also people were trying this. Then in 1950s, uh, already few people tried to do something around this, but the problem at that time was computing capacity. The computing capacity was not there. We did not had high-end GPUs and TPUs at that time. Hence, it was all theoretical concept at back then. So now we will quickly go into talking about what is AI. So we all know, right? AI is artificial intelligence, which means we are trying to bring the human way of thinking into machines that they can also learn, and they can also make decisions, solve problems on their own. And we have been seeing this AI thing in all the softwares that we have been using till now, because we are a big consumer of software. India is a big consumer of the software. We haven't built anything. We haven't built Netflix. We haven't built Amazon. We haven't built uh, any big names. We don't have let's say WhatsApp. We don't have Instagram. It's everything built by US, and we are just consumer. And there, if you see, they basically already apply AI for recommendation and for those kind of things. Already AI is done in the background even around 2014 15, since that time, but in small way, using the small models or training them in the deep learning technology for specific use case like classification or categorization or recommendation. But now it is becoming bigger. The same idea is now going into in a big way, because they found now big computing capacities, but also new architectures, which I will talk about, to get this thing uh, even bigger in terms of shape and size. And machine learning is part of artificial intelligence. Artificial intelligence is basically, you can say, like we have science, arts, and commerce, right? Same way, artificial intelligence also a field. And part of that field is machine learning, where we feed the data to the machine and we try to make the machine learn from it. The machine will learn from it some new patterns and new things, and it will basically later on, if we ask something, it will use those old learned patterns to predict something or categorize something in the new world. So, like, if you want to, if you want to have a computer, right, to tell whether it is a photo of cat or dog, You basically first train it with many cats and dogs photos and tell it what is a cat, what is a dog, and later on, when you show a unknown picture, it will be able to tell you what it is. So this is how it looks like. Artificial intelligence is a big domain, and then machine learning is a subset of it, and deep learning is even subset of machine learning, but this is a specialized learning where machines are learning but from huge data set, and they are working on multiple features. And in deep learning now there's large language models, LLM, vision models, they are part of further deep learning. So this is how it all flows: artificial intelligence, machine learning, and in the machine learning we have supervised learning, unsupervised reinforcement learning, deep learning. And then in deep learning, there's a new architecture called transformer architecture, which was used to create GPT model. So, and then these GPT models became popular. So now quickly let's go through these topics because these are important. So let's understand this supervised learning with a simple example. If you say what is the definition, basically supervised learning is a type of machine learning where the model learns from labeled data. Input and the correct output both are provided during training. Example, let's say if you say Ravi is a student who goes to school, and Ravi's teacher shows him an apple and say this is an apple, and shows a dog and say this is a dog. Every time Ravi answers this thing wrong, let's say to apple he says no this is orange, then the teacher is correcting him. And this way the teacher is actually making Ravi learn, but via supervised manner. Whenever he is wrong, she is saying you are wrong, and this is not orange, but this is apple. So that's where input is given and also correct output are provided, which means uh, data is given to the train, but correct answer is also provided. It's like MCQ questions with also tagged with the right answer. So then the way of learning of this machine is supervised. And after that machine learns this, later on if you provide something unknown, then it recognizes it. But here there are certain problems because you have to find so much data. You have to also you have to tag the data, what is the correct answer, and then use that data. So it's so much of effort goes into that. Example, the initial world, automatically the emails were detected as spam and not spam. That's an example of supervised learning. So you can remember these things as this example. Same way, unsupervised learning. Here the model learns from unlabeled data. You just give data, you don't say what is correct or non, what is not correct. You don't do that. So this is much easier way, which means whatever we are doing today, like we are sending WhatsApp messages, we are uploading post, or we are uploading, let's say, writing an article somewhere, or um, putting anything on internet. All those data is directly fed into big models by Meta, and then model is, and no Meta employees don't have to sit and label them. The model is automatically identifying patterns between those, and they are recognizing those patterns, and they understand, and they are creating some kind of model out of it, and that model is being used for suggesting something to us or categorizing some things. So example, customer segmentation, market basket analysis, and pattern discovery. Again, if we try to relate to Ravi's example, so let's say in this case, Ravi's teacher did not show an apple or a dog. Instead, what Ravi's teacher did is she gave mixed toys like cars, teddy bears, and balls. And then Ravi, while playing, he could recognize a teddy bear looks like this, so he started to make all the teddy bears in one place. As he started putting them, ball he started to put in another bucket, cars in another bucket. So he did it by himself. How? By recognizing one or more feature of that object. Because car looked different with wheels, the teddy bear looked different with nose, eyes. Ball had a different shape, size, and form and touch. So he himself was able to get that knowledge, Ravi. No one told it. It recognized the patterns between the different objects. So he grouped all these things together, which means no teacher was involved, and Ravi found the patterns himself. And in AI terms, you did not have to use label data, which means less human effort in training the models. And modern model itself finds hidden groups in the clusters of data provided. Are there any questions until now? Until for what is machine learning, what is AI, what is supervised, what is unsupervised learning? Any questions from anyone? Hello, am I audible?
Hello, Ranjan.
Yeah.
Hello, Ranjan. So basically, with the examples we can understand is, but what's the main difference between supervised and unsupervised? So there will be a trainer who will be giving the inputs, and then we will expect the correct output in the supervised, right? But in the unsupervised here,
So in the supervised, there's two things, huh? You
yeah.
provide the data, but also you tell what is the
Hmm.
correct answer
Okay.
out of that. So it's like you, if you have given exams, MCQ questions are given, right? Multiple choice
Mhm.
questions. So
Right.
let's say they ask what is the capital of India, and you have four options. Okay.
Mm-hmm. Correct.
So in supervised learning, you will get what is the capital of India with the four options, and they will also mark Delhi. Delhi will be
Okay.
already rounded off. Okay,
Okay.
which means the in data is given to you, and then answer is also already told to you. Okay,
Okay. Okay.
and they do this with many questions, and then finally, after the model is trained with this supervised learning mechanism, they will
Mm-hmm.
come and ask you a question related to what is the capital of, let's say, uh, yeah, I mean, they can ask any country, yeah? What is the, or any city, even they can ask any city. Then this
Mm-hmm.
model will, or it knows from the past learning, then it will try to answer that.
Okay.
Okay. But then here in supervised learning, you don't do that. You just keep giving data in forms and not tell what is the correct one. So let's say, same if we take the uh, some questions, right? Maybe we take a simple example of resumes. You give so many resumes to this. When you are doing unsupervised learning, you do give so many resumes. You give resumes of, let's say, nurses, teachers, IT professionals, DevOps professionals. You just keep giving that, and now the model will automatically know who belongs to the nurse category. It will put all those resume on that side. Who belongs to IT sector, who belongs to, let's say, a sales sector. It will automatically do the segregation by identifying the patterns, like, because IT person will have some skill sets which is very different from the non-IT person, so it will automatically know that, which means you did not wasted time in giving the right answer also to it while training. Got it?
Okay, okay, got it. So the here the main basic idea is so pattern discovery. So based on the different patterns, so it will be data will be segregated or any kind of the.
Exactly.
Okay, okay, fine, fine, noted.
And now deep learning is little bit the next level. So as I said, right, I showed this box. So you have artificial intelligence and machine learning. In this machine learning, you have supervised, unsupervised learning, and then deep learning. So you see, now we are here, deep learning. So deep learning is slightly higher, let's say, dimension of learning. Example, when Ravi sees a dog, then what he does is see. Because till now, we were just talking about one or two attributes or features of a particular training instance or model, right? So now, basically, when uh, Ravi sees a dog, he sees this animal who is animal. He, because he doesn't know it's an animal or not, but it recognizes there's a shape of, and there's a form of it. It has a color. It is sounding. It has a tail. It's also moving. So what happens now is, it has Ravi has to now visualize all these inputs. Earlier, if Ravi was asked, this is what is this? Is an apple or this is an orange? So it was able to detect it with one feature, like maybe color and shape. But here now there are multiple features on which he has to take a decision. What it is looking in front of it. So many thinking layers. are going inside in his brain. Same happens in our brain also. When we see something, we there are lots of neurons that get fired, and their connections and interconnections changes, and then only we are able to tell something about that, what is in front of us. And that too, we are able to do that because from the past knowledge. Let's say if something weird comes in front of me, maybe an alien comes tomorrow from another planet, and that alien has a completely different shape and form which haven't seen even in science fiction movies. I will not be able to tell what it is because I haven't seen that. Then my brain will learn again, will try to find more answers. And if similar alien object or alien comes in future, then I might be able to tell that yes, it is something unknown. In the past, I have seen once, and that is that unknown thing. So same way, in deep learning, what happens? There are many neural networks that we have to build. I mean, the here in the supervised and unsupervised learning, what we were doing is, let's say, we were training the model only in one layer, considering small features. And what are features? The input on which we train the model. But now in the deep learning, we give lots and lots of data, and the data can have many parameters or attributes. And then w- based on this all the attributes, it will try to form relationships between each category and then try to find pattern. Hence, if you see, deep learning uses many neural networks to learn complex things like faces, voice, language. When you say faces, whether the person is smiling, laughing, or crying, all those things. So, if we try to understand in the, let's say, in the deep learning way, like it's also a subset of uh, multi-layer neural network. And we will talk about the neural network CNN, RNN later. But just assume that there are many layers of learning, uh, and one output of one layer is fed as input to another layer, and then all the learning layers combined together, then they are able to predict something or categorize something. Individual layer makes no sense. So this is exactly what is inspired by human brain. This is what happens in our brain also. So to find images, the CNN neural convolutional neural network is there. RNN is there for sequence. LSTM became very popular for stock market prediction analysis. All these were before this large language model came. These were the very popular ones. And finally, the transformers came. Transformer architecture is even smarter than these deep neural networks, those things. And what is that? I will explain in a minute. But this is modern natural language processing that was built on transformer architecture. So this what we have now, this deep learning, they all were used for this kind of use cases in the past. Because you remember self-driving cars concept was coming way earlier than uh, what we see today. Self-driving cars, Google already introduced long time back before GPT or other things came. So how? Because they were still doing machine learning but using deep learning concepts. Then there's another type of learning that we can do to make the machine learn is reinforcement learning. And here it's like reward and punishment kind of mechanism. So if you give a task to a particular model, then if the model does that properly, you basically give it some kind of reward, and then the model gets appreciated and it is doing things correct more and more. But uh, if the task the model fails doing that task, then you basically uh, punish that model, which means the model will not, whenever next time this kind of task is given, it will not make that it will not do that things wrongly. Instead, it will try to do it properly so that it will get some benefits out of it. So here, if Ravi is, let's say, riding a bike and he falls, then you don't give any reward. But if he rides his bike properly, then you say you will get a chocolate. So it's the same way you write models. Huh? And when I say model, it literally doesn't mean that you are writing the model. You are writing, there's different algorithms in Python. Using Python, you can write those algorithms, and then you can use those algorithms on the data set, and then that algorithms will generate something which will be called as models. And these models will be used in future for prediction, classification, generation, that kind of things. So there are this whole AI thing is a little bit different from the regular programming world. If I ask you to write a program to identify an apple, you will write all kinds of logic. I- If the color is this, then it can be an apple. If the color is either red or green or something, then it can be an apple. Then you have to write another code to check if the shape is like this, and then it can be an apple. But then with traditional programs, you can't solve these kind of complex things, real world objects. How to write a code, write a Java or Python code to find out whether a dog is running or dog is crying or dog is barking? It's very difficult because these are not traditional, these are not things that you can solve with traditional programming. Hence, this whole concept of uh, concept change in traditional programming, what you do is you have a problem at hand, you write an algorithm to solve that problem by considering all the let's say the scenarios. You write those scenarios in your program, then you pass an input, and then you expect a certain output. And if the output is different than the expectation, you go and change the program. Then again you pass the, once that it works, then you say it is working fine and this is my algorithm, go ahead and use it, and it will be used that way. But in the AI world it is different. You don't write program, you just provide input. You continue to provide input data, and from that data a particular, let's say regression kind of scientific, or there are different scientific algos which are there for different scenarios. You write that one particularly, and let's say for prediction you go for linear regression, and then you write a piece of code that will do linear regression, that will take input and try to create a model that will do linear regression, which means you provide lots of input and you get a model, with that model can be used for solving future problems. So basically you get a kind of a code as an output of machine learning, and that code can be deployed anywhere and it will work same way like the GPT, the, let's say the chat GPT thing. It is just a front end which is calling by API a model which is trained with lots of data, and that model is running and it is getting an input and it is trying to find a pattern of that input with all the existing pattern it has built so far, and it is trying to give an answer in form of a next generated sentence or next generated piece of code. So that's how the whole traditional coding and the artificial intelligence differ. And then this is very important, transformer architecture. The transformer architecture revolutionized everything. Before this, it was very difficult to do machine learning because with deep neural networks, you have to write multiple networks and then tune those layers of those network to get a proper output. And if something doesn't go well, you have to redo it again. So it was months and months of work. But with transformer architecture, we will not go into details now. We'll do it later. What happened is, let's say example, uh, Ravi's teacher told Ravi that the monkey didn't eat the banana because it was rotten. And Ravi was smart enough to find out what does it means in this sentence. Does it mean the monkey or the banana? So how did Ravi come to know about this? Because here Ravi paid attention and it understood. It here means banana, not the monkey, because in the past the data it was trained, he must have encountered similar sentences, and there he must have found, if it is something, let's say talking about rotten and these words, it is more relatable to a fruit or vegetable than to an animal. Hence it was able to, when a sentence was spoken, Ravi understood it as a banana, not monkey, because he paid attention to the important words. Same way in the AI world, the transformer architecture uses self-attention, and it looks for all the words and understands relationship between them. And then this particular concept was introduced in a white paper called "Attention is all you need." So somebody came up with this idea that no need to do all this deep learning, this all this CNN, RNN, not required. Let's somehow write an algorithm or create an architecture where we give lots of data, and that algorithm or architecture is just able to understand the relationships between the word, the closest relationship, and that's it, is what you need. And that this gave the birth of what we have today, the whole large language models, large vision models, this transformer architecture. And then now if you talk about on top of transformer architecture, how OpenAI company build this GPT? Basically now you give this transformer architecture maybe thousands and ten thousands books of storybooks, let's say storybooks. And in those storybooks, a lot of things were written once upon a time, and then this it continues. So if training was used with massive data, then this model were able to predict what will be the next words automatically, because in the past they have seen so many stories. So now if you ask once upon a time, and then you will see automatically it will try to predict, okay, the most relevant sentence for this particular starting sentence can be this. Hence it's very important that you write a proper or good prompt. Otherwise, what is a GPT? It's basically generative pre-trained transformer, which means it is built on a transformer architecture, a big mega model with huge data it has been trained, and then it has those with those data it has built lots of patterns and relationships and knows what to predict next. But then if you don't ask the things properly, it will try to mix up things, and that's what, or assume things, and that's what we call hallucination. Hence, when you ask something weird, let's say if you ask your friend something very let's say abstract, what answer you do you get from your friend? Out of courtesy, he may reply to you something, or he will say, I don't know what you're talking about, right? But models don't do that. They will try to give some answer, but then those answers may not be 100% correct. Hence, it's very important you ask. Let's say if you want to ask ChatGPT to write a poem, then tell what kind of poem you want, who will be the audience of this poem, will it involve rhythm or not, rhyming words or not, or can it use some humor or not. If you give all this detail, you will get a very perfect real world output, because then it is relating many things that it has learned, and it's trying to relate to each of the input in the prompt that you have given, and then it is able to generate something. That's why people, while giving prompts, they also give some examples of the output they expect. So this GPT, which is the disruption that happened, and then it was built by OpenAI company, and the first product they launched was ChatGPT, which is a chatbot, and it basically answers everything what you want. And then you can call this GPT model as smart storytelling kit. This particular one who only read stories, but if it read stories, it read science books, it read coding GitHub repositories, if it read all the tweets, if it read all the news articles or general knowledge, then you can say it's a smart encyclopedia. And that's what GPT is today. It's a huge model. Same Gemini is also a huge model. The Anthropic Cloud is a little bit tuned more towards better coding compared to all the things. So these models, you can also create your own GPT models, small ones for a specific purpose. Let's say you can create a model that would only tell you stories. So you train it with 20,000, 40,000 stories, and then you use that models for generating new stories. Or maybe you can create a startup where you can say that I will train a model, I will train a small model, not big one, so that I don't have to invest too much cost in training it, and also when calling it while deploying on the server. So what you can do is you can go and train that model on all the Bollywood movies, stories of all the Bollywood movies. Just train it, or even the songs of all the Bollywood movies. And then This model will become, let's say, a lyrics writer or the story writer of a Bollywood movie. You can call this model, and then you can host this as an API, start to sell it as a service for Bollywood industry, and then you can say for this many tokens or this many things. We will learn about what are tokens and other things to the models. You charge some money. So if somebody wants to release a new film, art film, or any kind of mainstream film, they can come and ask for an idea around certain concept. They will give that, and your model will be able to give a full full, I mean, sequence by sequence of characters and the stories and narration of that movie script. If they don't like one, they can create multiple. So you can do that kind of business also as a startup. You can create your own. I just give one example. You can do it in all the industries. In the legal industries, they are already doing. They are creating lawyers. In finance industries, they are also creating CA, chartered accountants models. And in education sector also, they are doing a lot of things. There are a lot of things happening in all the sector because it's so easy to build something like this on a small scale. So yeah, to summarize, the AI is like a smart robot world. Machine learning is robot who goes to school. Supervised learning is teacher teaches the robot. Unsupervised is robot learns alone. Reinforcement learning is robot learns by rewards. Deep learning has a big layered brain, which it learns in multi-layer different features. Transformer is robot pays attention to the words, what context the word is told. And GPTs are the outcome of transformer architecture, where the robot becomes expert storyteller in this case. So again, this is the same thing summarized here. And now we are going to go to agents. What are agents? So now, so far, what we learned is a brain, only a brain. Just imagine as a human, you only have a brain, nothing else. No hands, you have ears, you have eyes, and you can speak your mouth and a brain. Just you have the head part in your body. Is it of any use? It is of some use because that is what these models are like ChatGPT. What it is? It is just a brain, and the Gemini AI and the Whisper AI. They are able to give you something when you try to speak. They are able to translate the language part into text and then convert back the text to language, and you are able to hear something. When you show a picture photo, it is able to identify, which means it also has eyes. So till now, the industry was building the head part of the human. You can say that way. They were building the brain, which is the LLMs, then the eyes, ears, and they haven't built the nose till now. Nose they are trying to build, which means smell. It will be also able to generate artificial smell, fragrances for certain scenarios. Researchers are trying that also. They haven't been able to build emotions. They are trying, and that can be also soon achieved. But at least they have built the main parts of human. And now it's about the body. Because if let's say the agent or the LLM model wants to do something on its own, it is seeing that in front of it there is a room, there's a air conditioning running, but then and no one is in the room. The model is seeing that this no one is in the room, but still the AC is turned on. But it is helpless, it's not able to do anything. So now with agentic AI, the next step is getting introduced. It's basically getting the body, which means it will be able to talk to the other system and take actions on it. If it is seeing no one is in the room, it can connect to that air conditioning system by an API or via a call or something and turn it off. So now slowly this is going to become even more and more available. There will be robots on in which will fit this intelligent brain and also the action taking agentic capability, and then it will become a human, which means if I want to build myself, I want to clone myself 5 times, I have to build a GPT model, which will be a multi-model, be able to talk, able to speak, able to learn, and able to predict or do things. And then, if everything for my life till now, I will be able to train to that model. Then I've created another Ranjan, and I can copy it 5 times and put it in different, let's say, machine boxes, maybe with certain hands and legs in it. Then that person is also a Ranjan. You can ask questions, it will be able to reply like me because it is exactly trained like me till now. So it will be able to, in future, it might become different than me altogether, but at least until this point, it is me. So that is also where the things will go in future, like cloned humans, and cloned humans will be like this. So, and scientists are even trying that. They are trying to download human consciousness and trying to put it into these kind of trained models. But yes, now if we talk about agentic AI, how it is different than the smart kid storyteller. Here we had this smart storytelling kid who was only trained in this and was able to tell stories. But now, let's say this kid becomes bigger and grows, then it is able to take independent actions. So now Ravi grows up a little bit. Earlier he was only answering question. Now he starts doing task on his own. Example: if Ravi is asked to prepare a science project. Now Ravi knows what to do. He will plan the project. He will search different books, makes notes. He will draw diagrams and build small models out of some small artifacts, and then he will submit the project. So what is this? This is an agentic capability that Ravi is doing. All the things he needs to do to achieve a task, he is able to do that. And he knows how to do that. He is not going to make drawings first and plan later. No. For planning and let's say searching books, he knows for searching books, he has to either go to library in his nearby locality or school, or he has to search online on internet. So searching online on internet is a tool, let's say tool. Going to the library is another tool. Drawing diagrams is another tool. Building models is another tool. And Zavi is an agent. Basically, Zavi himself is both. He also has the intelligence, and then he is going to use one of these tools to, and with his intelligence, he knows which tool to use when, and then he is able to achieve that work, create a science project on solar system. And for doing this, the best part is the teacher didn't guide anything. Teacher just gave a use case, and when Ravi may be asking questions, then maybe some hints or inputs. But all other things he was doing independently. And this behavior of Ravi is called agentic behavior. And this is exactly what we are seeing. So if we in one line try to say what we are doing now, we are actually building humans and superhuman species as a new capability in the world. Yes, Ramesh?
Yeah, so yes, Ranjan. So at this point in your previous screen, so this yeah, so Ravi plans to do. I mean, he will plan what to do, and then search his books, and then notes, and then draw. I mean, he will draw everything based on the project, and then based on the input, right, according to the task. So similarly, coming to the GPT, be it any GPT, I have a basic question. Like maybe it's a little early to ask, so if we give any prompt for expecting some solution, right? So the prompt can be like anything. It's related to the code based question, or it's related to the stock based research, or it's related to researching, or anything related to generate a image, something like that. So all we will get results basically from that GPT. So all these results are basically trained and given to the GPT to give particular results, or it will search the internet and it will give the results for us. So what is the best approach which is trained for them, and how the that GPT will give results for us? I
Okay.
have this basic question. Yeah.
Yes. So these GPT models are already trained on the data, so they don't know what is happening today. They don't know that they are not connected to internet. But with agentic capability, what you can do is you can build a tool that will connect to internet for a particular requirement that you ask GPT, and then the LLM, the large language model, what it will do is it will know if a question is being asked around certain thing and it doesn't have the input or context of it. It will make use of that tool to call internet and get the internet searched for it, get the results, bring the result back, and then apply the LLM intelligence to customize it according to the question that you had asked. So basically it got the real time information from internet via the tool that you have built, but the intelligence it will use what was it was trained with. Like if the searched item is relevant or it is useless, it will decide with the intelligence of the LLM. But the actual item content, which is the real time, it is getting from internet, and for that you have to build tools as an agentic AI developer. Got it?
Okay, so we can say it like it will actually search the internet and it will, based on the results, so it will summarize the content and it will give the most appropriate result for us in a best way, right?
Exactly,
Most
exactly,
of,
exactly.
okay. Instead of just, I mean, basically when we search something in the Google, it will give the links for us, but here it will search the internet and it will give the summary of the context or results for us in a best approachable way, correct?
Right.
Like that. Okay.
In future we will build many agents, and I will show
Mm.
you how to build even a search agent with a Google agent to agent protocol or Google ADK kit. We will build agents. You will see, you will be able to connect the whole internet and to
Mhm.
your LLM and
Okay.
build use cases around it. If you saw yesterday's use case, when
Mhm.
Subrat was asking in the RAG, the chatbot about the society, he asked some nearby questions. The nearby questions output was, some of them was coming from what it found in the documents, and others were coming from a Google search the agent was doing in the 3 kilometer radius and getting the responses. So you can combine all the worlds. You can combine the database information which is you have. You can combine the documents to search also. Basically, you can create multiple tools. One to search your database, one to search the document system, one to search internet. And now agents will use LLM to decide when to use which tool. Let's say now you prompted something, do the research on my sales. Then as soon as you wrote my sales, then agent goes with this query to LLM. LLM tells, if it is my sales, then I don't have to go to internet. I will go to the database and I will go to the files. So it will use the database tool and the file tool to get the data and do the analysis and result it back. But let's say uh, if somebody asks the agent, can you do the analysis of my competitor for this particular last year? And that the competitor was, let's say, if HUL, Hindustan Unilever is doing an analysis on ITC, then automatically, because it knows the competitor data will not be present in this person's database, so it will go and use the internet tool, call internet, get all the reports or the financial statements filed by ITC in SEBI. It will download those and analyze those reports. You got it? Like we as
Yes, yes, yes.
like we as human do, huh? We as human, what do we do? If we are asked a question or given a task, this is what we exactly do. We reason out, right? Let's say somebody tells me, go to the temple on this date. Then I will not go to a school. I will go to the temple, right? Because I've been asked to go to the temple. How did I decide it? Because in temple, things happens around ritual and God. and school education kind of things happen. So somebody said temple, so and then said on this date because of some, let's say, festival. So I was able to relate, because for festivals and other things people go to temple. So my LLM in my head was able to process that instruction, and it was able to tell me to go and follow the direction of the temple. Got it? Same way it is happening in this artificial world. That's what I'm saying. We are building the exact human species, and unfortunately it is becoming more smarter than us, because we our learning, we are not one human, right? We are not human, one human. All the people on earth is not one. So everyone has learning in bits and pieces. We are small LLMs with other capabilities like vision and audio, but they are building one large big LLM, which means it has the learning of lakhs and crores of people or brain combined. So definitely it will be more powerful than us, right? So now we will go to this architecture of an agent, because now we went through different parts of that. We went through the journey of learning, supervised learning, unsupervised learning, the deep learning, transformer architecture, and then GPTs, agentic AI, and now we will see under the hood how it works. What is the architecture? So agent is just a piece of code that we will write. It can be a piece of code, it can be a piece of instruction. And then that agent needs few things, few tools to do some things based on what you are building the agent for. Because every agent should be built for a purpose. And to serve that purpose, if you need calculator access, then you build a tool to access calculator. If you need calendar access, then code interpreter, searching internet, or maybe doing a query in the database. So you build tools. Number one, agent needs tools. But without, if you have simple use cases, you don't need tools also. Then agent should be able to plan and check its own planning, and then say if the correct, it is planning in the right direction. If it has critical feedback, then it will replan, reflect on it, and then it will use the chain of thoughts. What is chain of thoughts? It is basically combining different parts, because you can have complex requirements. Let's say you want one of the agent, you are building an legal agent. You cannot build one agent, you will build a multi-agentic system to replace a law firm. What does happen in a law firm? There are many small departments. People are sitting there, they get files of the case laws. Then they read the case laws. They first categorize whether it belongs to family law or Hindu law, or it is a law around property transfer, or a criminal case. Or first they segregate that. Then what they do is, did in the past they had any kinds of this kind of cases? Then they check, was there a case around this topic in recent years, but some hearing done by Supreme Court or High Court. And then finally they prepare the combined output and put it in a file, or on a soft copy on the desk of the senior advocate. So when the senior advocate comes, he quickly goes through that, and then he knows the what to do the hearing for next day, and then he tells, okay, prepare a drafting on this for my next hearing in the court. Then those juniors will come and go ahead and prepare a drafting report. Now this process, I myself can automate it. I can write, with the current things and tools available with us, I can write a multi-agentic system that will replace the whole law firm. Maybe you cannot completely replace it now, because again it's debatable, it's law. But you don't need let's say 20 people to run the law firm. Maybe 5 people can run that law firm with this agentic system. What I will do is, I will create an agent that will read the documents, scan the documents. It will be able to scan. So I will use a LLM model which will be having OCR capability to read documents and extract the text information. This is one agent I can build. Second agent is, it is trying to categorize to which case law it can belong to. Third, looking on the internet or all the court websites for the recent case law which is relatable. Fifth is preparing a summary, and then a top agent which is a manager who is orchestrating these all agents, and finally preparing an output report for senior. And then there is another agent which will be basically taking instruction to create a drafting based on the input provided by senior, and then an agent which connects to the printer to do the print. That last agent I can do a voice enabled, which means as soon as the senior reads the document, it can open its phone, maybe an app or a website in the network, and say, okay, I read through this report, it looks good, draft me hearing drafting for tomorrow's hearing, and you should make sure these are points captured. It will translate that to text, the agent will process that, and then if an instruction was given to do the print also, it will send the instruction to the printer via another tool, print tool of the printer, and it will be printed. So you understood what I tried to explain. You can replace a complete law firm. Same way you can replace almost everything that exists in the real world today if you think little bit critically. That's what people sitting in Anthropic and those companies, they are doing that. They are reasoning what else can we replace, and they are building tools or plugins and they're replacing it successfully. Any questions or doubt in this use case or any other things? No? Okay. So here, if you talk about, I explained agent needs tools. You can continue to build these tools, and these tools can be built in any programming language. You can use even CoPilot to build this code of these tools also. It can be written in Python, PHP, .NET, Java. One tool can be written in Java, one can be .NET, one can be PHP, one can be, let's say, Node.js. It doesn't matter. The agent is smart enough to detect the technology and process the tool. Then let's say the I was talking about this example of the law firm, right? One agent did the research and it found out it has to categorize in that mode. Then what we will do is, let's say the senior, when he was presented with report, wanted to cross verify certain thing. So if the agent did not store the intermediate steps, thinking and outcome input processing, then when the senior would try to recheck or revisit, then the agent has to do everything all together again, and then it will be a costly business because LMs will use more tokens. That's why the memory is important, short term and long term memory. So while building agents, you can keep certain things in the long term memory which will be used for all the future use cases. Let's say, uh, example in the past one was recent case laws, the hearing that was done in Supreme Court, High Court. Until today's date, whatever analysis, if this agent has done for one kind of scenario, it can be saved here, right? So that in the next time for same kind of scenario, same case of, let's say, the property fraud case comes, it has already looked into the High Court and Supreme Court case laws until today. So it will read that data for until today from here, and for the next one it will go the latest one and update it this. Same for short term memory. It you can decide to store some short term memory event that has happened in this, and that's how you can use memory to save cost but also rework. Same way, planning. So here you can, instead of agent, if I put a human being, then I'm not wrong. I'll just put a human being here. Human being needs tools to do work. Human being has memories, the subconscious mind, and the main brain, like long term, short term memory. We do planning, we take actions, we do critical thinking. Sometimes we also think like, oh, did I miss anything? Should I have to go back and recheck? We divide the task into goals and try to achieve them. So, and then we have a brain that helps us at each and every step to take decisions. So agent is basically us. If I'm a software developer, then I can have build a software agent. If I'm a lawyer, law firm, I can build agent or multi-agentic system. If I'm let's say working as a customer support person, there can be agents built for replacing them. So agents are one to one or one to many replacement of humans. We can easily tell that statement the way things are going now. So now I think we have covered a lot of theory. As I promised, we will also go through demos and practicals that you can already do on your project starting this week itself. Before we go there, are there any questions?
Oh, yeah. Yes, Ranjan.
Yeah.
So basically, when we develop something, a new agent, AI agent, basically, so where do we need to host this so in any cloud environment or any space so that it will be available to utilize or something like that? So how it will be done?
Yeah, so it is a big thing. That's why you
Mhm.
see, if I start telling you all this to today, you will stop doing the course, you will get demotivated. You see,
Oh, okay.
we have this whole thing.
Okay.
So we will slowly grow from the simple things to complex thing.
Sure, sure,
Now,
sure. Yeah.
now we are here.
Mhm.
Uh, and I should not be even showing to build agents today, but I thought, okay, let's show you all to build small agents so that in this coming week you can practice in your organization.
Okay.
For these kind of agents example which I prepared here are very useful, and it doesn't even need any single line of programming knowledge. Only English text is needed. English, if you know English, you can build these agents. But then all these are covered. See, there's a sequence in which you will go, and that's why
Okay. Okay.
it's very important to attend these classes, because just think, in human history we are building things to replace ourselves. So it is, let's say, funny, but it is what we are doing, and now we should be part of that, otherwise we will be lagging behind. So here, to build the agents of today, you don't need this. We don't need to install Python or Git today. We haven't learned, so we'll not do that. What you need is to install VS Code. So VS Code editor you have to install, and you can go to internet and type VS Code download. If you, because it's easy to download from internet, but when you are part of organization, then in every organization, depending upon what software you use, there's a software central team where approved softwares are provided, or there's also a company portal where approved softwares are provided. So there you will definitely find this VS Code editor. So based on your requirement of what operating system you use, you can download this and install it. This is first thing that you do. Then the second thing is you should have one GitHub account. Just go to github.com. You can create one GitHub account for yourself. If you don't have one, you create a GitHub account. So as soon as you do these two things, like download the VS Code and have a GitHub account created, then you are done. But if you are in your organization or company, there will be a process. You have to ask that process how to get access to GitHub Copilot on VS Code. So what they will do is every company, they have a department called GitHub Copilot or Cloud Software Tool Access. You ask what's the process and get access to that. Once you get access, they will also provide you login. This is what I'm talking about in your company, how you have to do. If in your local, then it's fine. Just download this VS Code and with your GitHub account, login. That's it. You just log in here, done. Then you will start to see here something called chat. And then I will show you how to use this chat. First, I will show you how to use Copilot. I don't know if uh, you all have experience using this. Has anyone used Copilot till now or not? Is there hands?
Yes, I have used.
What about others?
I'm using daily.
Okay. So my suggestion to you would be, if you are not using it, you are on red zone. You are directly on the red zone. If the organization has provided you and you are not using it, you will be in big trouble. Start using it today itself. And then if you go to Copilot, here there is two things: agent mode, plan, and ask. Many companies were giving only ask mode initially, which means if you ask something, it will basically uh, give you response in here itself. It is not able to take any action here. And you can use one of these models, Gemini models, Claude models, GPT models. This is the free version which I am using. But you can also add premium models. But if you are in your company or organization, they provide way lot more models you will see from here. So you can choose any of the models. The best ones are Cloud, Haiku, Cloud, Opus, or Cloud Sonnet. Best for coding, documentation, anything related to IT sector. Then GPT Max Codex is on the next one. But if Claude is provided, go with it. Otherwise, Gemini 3 models are really good. Otherwise, GPT 5 Codex Max, those models, they are really, really good. When I say good means here, right? The brain, if the brain is garbage, whatever you build will be garbage only. So this is these models, what I'm showing. So go for smart models. Let's say now I'm in the ask mode and I tell it to capital of India. Then it is going to answer me here itself. But if I go to the agent mode and tell it, can you create a file on root level, capital.txt, and write capital of top 10 countries along with their coordinates. Now I'm in the agent mode. If I do this, it will take action now. What it will do is, it will create on this root a capitals.txt file, and it will try to put the thing. See, it's saying creating. You see, then I have created this file, and it will ask you to keep this. So it is saying one file change. You can also review this file, open changes in this editor. So there was nothing here earlier, and now it created that file. India needs this, coordinates this. See, I could have asked it to do it in a much better way. Let me undo this. Then it will not, the created content is gone. I will ask it to do it coordinates. Make sure the output is in table format. Also mention the prime minister's name for those countries and the army size. And then I can say created markdown file, MD markdown file. So now it's going to create a markdown file for me, and it will include capital, coordinates, prime minister, leader, approximate army size. It's doing that now. And now if I keep this, what it has created, here's the file it created. If I preview it, it exactly did what I asked. Top 10 countries, capital like this, with the army size and other things. So this is one example I gave how to use agent mode. So let's say here you have code in this folder. You can ask it in the agent mode to read this code and then go ahead and do some summarization, analysis, review, whatever you want. You can do that. So agent mode gives you power to write something, read something, and modify your existing file system. It gives you that capability, the agent mode of Copilot. So if you're people who are not using, just imagine what you are losing here. So now, next question is, if let's say I have to create some things around Copilot that I want my code to be in such format that it is adhering to certain coding standards guidelines. So there are multiple ways. There's something called Copilot instructions file. Many companies uses this. So this is a Copilot. So you have to create a folder wherever your project is, and .github folder. In that you have to write copilot-instructions.md markdown file, and in this you have to write things. You are an expert Java developer. When writing code or reviewing code, strictly adhere to the following standards. Code style and formatting, it should follow this indentation. Classes, it should be following this naming convention. Documentation should be like this. So I'm doing this for Java. You can do it for Python, PHP, .NET, front end. You can, if you are a business analyst, you can use Copilot and have an instruction, provide certain other instructions when you are doing your own BA kind of work. So now let's say this is a code. How this instruction file works. There is an ugly code. This code does not have any kind of indentation or anything. So what I will do is I will ask this Copilot. Let me keep a backup of this ugly code. I already did it. It created, I asked it to create a good code, and it created it with all the, it gave the comments here. It aligned it, see all the indentation, everything with proper things it did, followed proper naming convention. But how do you invoke this instruction file? Basically, if you have this GitHub, it's inside the GitHub, any project in this workspace, this GitHub Copilot instructions will work. So it's very simple. What you have to do is, here you go and tell, I will delete this. Otherwise it will override it. Or I can even ask it to create. So I will just go to the agent mode, and here I will say, I will be in the agent mode, agent, and I will say, do one thing, follow the instructions, Copilot instructions file, and convert the ugly code Java code into as per instructions. So you will see what it will do. It will go and look for the ugly code. So it found the ugly code. It reading. See, it read all the instructions. It read the instructions also, instruction file in the root of .git, and then it is replacing 20 all these lines, refactoring all these lines of ugly code automatically. And it is going to do that, and he said, I have done this already, done, successfully done. I will go ahead and keep this. And if I now go and see, the ugly code is getting converted to nice code. So every company has certain coding guidelines, coding practices, other things. And if you want that developers don't skip that, you can create some kind of Copilot instructions file. So Copilot instructions files helps you do with these kind of things. So now, why do we need agents then? If Copilot instruction file is sufficient, why do we need agents? So agents, again under GitHub Copilot, you can create .agent.md file. So I have certain agent, PR review agent, stories agent, tester agent. I will show you what each agent does. Remember, these agents are not using any tool till now. They are not using any tool. They are using some inbuilt tool provided by Copilot, but I haven't written any external tool. If I have to write a tool, there will be also a tools folder at this level, and then I have to write the tool in a particular programming language to do something. But assume we don't know any programming language. Just with these agents, what we can do. So I've created a stories agent. What I've done is in this input data folder in the stories, I've kept 20 small stories. And now what I do is I in the stories agent I have told it what is your name, you are the stories agent, your description, what you should do. Basically, it should take the user requirement and read this tiny stories txt file in this folder, and this person is going to assume the role of a successful author with 20 years experience in thinking and writing creative thinking. Purpose, what it should do, it should write, if I ask it to write a new story, it will write that. If I ask it to extend on top of an existing story in this file, it will do that. If I ask anything else to do analysis on this file, it will be also do that. If the provided input is not found, then it will also suggest me the three stories around that relation. And I've told take the user input prompt and then keep the stories with 100 to 150 words, and it should be in the markdown file, and it should have an attractive title, body, and always end with a moral of the story. Now I want to use this agent. Then I will open the Copilot again. Instead of using agent mode, I will automatically see stories agent here. As soon as I select that one here, now if I say which story you found the most interesting one, I will just write this, and then you will see what it will do. It will go automatically. It is reasoning now, and it is going to inputs data folder in the tiny stories txt, and then it has found that the quiet hero story is very good. The story has a brilliant. So wait, not it says after reading through this collection, I found the mirror smile story number 4, the most interesting one. Here is why the story has a brilliant philosophic twist. Reframes all this. It says it is compact and it gives all this. That said, it also says the quiet hero is also a close second one. So if I go here now, fourth one, this mirror smile stories. So there are some mysterious stories, some science fiction stories. It has 20 stories. Let's say I will tell it, I will tell the same agent to now also, okay, can you elaborate further on this story? Then it will continue to extend this story. Just from few lines, it will start to add more content to it, and it will keep it around 1 to 100 to 150 words, and it will create some kind of markdown file. So see, it is creating that markdown file, and it is creating it the root. But how does it know what to do? I have already told that in the stories agent thing what it has to do, and it is following exactly the same thing. So now I go, see, now it has written what? It has extended on top of this, and it has a nice title saying Wizards Cleaner, an extended tail. It has a nice body, and it has the end with a moral of the story, because that was what I asked. Let's say, because I also told my agent that if you don't find a story with a certain name, suggest me something. I will say, uh, extend the story. I will just give any random story on um, the clever banker. And what it did, it went through all the stories and it said, I do not find any story around clever banker. And what it did, it said it gave me three story ideas: banker's gamble, banker's second chance, the numbers game, and it also gave a little bit. And now I can extend, ask it to extend on any one of them. It's saying which of these appeals to you. So what? Why I'm showing you this with an example. Now I will tell you how you can use this in your project in the real world. You can create a folder, put the files that you want to analyze, Excel, text, Word, anything, and do analysis on top of it. You can just do those analysis using this via typing in the agent mode. You can do that. But what will happen as soon as you close this prompt? You will lose all those interactions and chats and the formats and the other things. Using it as an agent helps you keep all these instructions in one place. You can even give this and share it with other colleagues in the project. They can also use it. And then you don't have to always remember this instruction. You can just use it as a story agent who is going to do certain things for you, which you have asked. Now, the reason of showing this is for business analyst, for product owner, for a user tester. Let's say there's a tester who has an Excel file of test scenarios or test data. He wants to do some segregation and analysis. What test data belongs to what category, or what test cases are doing for positive, negative. Put it in the folder, write an agent, ask ask the agent to do that, and from next time onwards, just replace the Excel or the file. It will do that for you. Even you can ask it to create separate folders and put those positive scenarios in one, next negative in another, and boundary cases in another. Even the test data segregation also you can ask. So that this idea can help you already doing a lot of things. Now I created another agent called tester. What this agent does is, it will look for a YAML file somewhere, let's say here, pet store open API YAML. If I open this YAML, you will see every company is built API, right? Without API, you can't have a software running. So this is a pet store application where pets are sold. So it has different API endpoints: get, post, update, delete, find, store, user. Okay. Similarly, you have in your company APIs, many applications. Now what you want is, you want to basically create an agent that will, as soon as you replace this file with another one, you ask the agent, it will create test scenarios for you. So if you see here, this is a senior software testing professional with overall experience. This is this, and then it reads this testing folder and then it analyzes and tries to create all positive, negative scenarios. And the output should be in the format scenario type, test URL, test data, test cases explanation, expected result. Now I can go here, or if I share this agent with anyone in the project, they can go to that agent and just say, start creating test scenarios. It is going to automatically look for the folder testing data inside this and look for a open API YAML or Swagger file. It read, understood everything, and it is now going to create the test scenarios file for me. It's evaluating and creating the different scenarios. So let's wait for it for the output. Meanwhile, I will show you a couple of extensions that you have to install. One is OpenAPI Swagger extension, this one, so that you can view the Swagger file as I was able to view. But there's also a Markdown preview enhanced for this one. This is the extension of that you should also install by Yi Wang Markdown Preview Enhance. That's why I'm able to see the nice Markdown files very nicely in the nice preview format. So now it's still evaluating and creating it. And now we are not using any tools yet. No, by default, whatever tools CoPilot has, it can use that one, because if you see, it will create a file with the timestamp attached to that. How does it knows the timestamp? CoPilot is using its own custom tool. The agent is invoking that custom tool because I might have asked it. So here, if I have told it that the output report, yeah, I told it. The output report should be in the format of API name and then this format, timestamp. See, it already created. It took the name of the YAML because I asked it to take the file name. I take the open API file name, which is nothing but pet store open API, and then underscore the timestamp so that you don't lose the previous run. And it calculated the timestamp using a tool which it has, and it took my machine's time and created that timestamp, and it appended that, and now it is creating that file on the root because I have asked it to create on the root. So let's wait for it to create that particular file, and we will see in that file all the test scenarios that it has created. So what I can do is, when I will learn, when I will show you how to write tools using Python, you can write it with any technology. We will create a tool instead of putting copy pasting these files here. We will write tools that it will go to a repository and download the latest open specific API specification, and on top of that it will run this and it will create this file, and for each of these test scenarios, it will connect to your Jira. We will create another tool, Jira or Azure repository, and then we will download that test scenarios and create that file. Hello, can you all hear me?
Yes, you're audible.
Yes, you are audible now.
Okay, you are not.
Yes, we can hear you.
Can you see my screen?
It's showing has started screen sharing. Yeah, yeah, I can see. Yes.
Now it's visible.
Okay, so it is still creating the reports. So the next, why do we need tools? The Copilot has not provided me a tool to connect to GitHub or Azure repositories or let's say GitLab or Jira. Those kind of tools I have to create. Maybe connect to Confluence or wiki pages in your internal. You have to create those tools, and that we will learn in future how to create those tools, and then we will give those tools context to our agents here, the tools, and then what are the tools, we'll give that. An agent will automatically know when to use those tools. So now it has created this file. Let me open this. So it says it has created 33 positive scenarios, 40 negative scenarios, 35 boundary cases, 2 regression scenarios. And now if I, because you should have this extension installed, as I said, Markdown Previewer, this one. If you have this one, then you can go to your file which is created, and it must be created here in the test scenarios. You see, I created a new one just now. So every run it will keep a file, and this is from the first one. Yeah, let me try to open this one. Okay, so here this is the one which is just created now. So if you right click here in the white space anywhere, you will see this one option, Markdown Preview Enhanced. Click on it, and you will be now able to see the preview of it. And if we go through it, you see the this is the positive test scenario, scenario 1.1, update pet with valid data. So what is the endpoint it has to use? Slash pet. Test case validation, test a successful update and existing pet with all the required. It gave you the test data which should be used. Expected response also it gave. Similarly, it created all the positive negative scenarios for us. So now just imagine how much time a tester will save. And if you integrate this with your pipeline, this test will be automatically also running and reports will be created. So you can already reduce the workload of a tester. Same way, a PR agent, pull request review agent. This is a PR agent. Assume that because I haven't built any tool to download the code and put it right. So assume there's this code downloaded and kept inside this input data, and there's this code here. So in the Java, this property management code is there. I've copy pasted it, just went to my repository, downloaded and copy pasted in this folder. But if I am smart, I will write an agent agentic tool that will go and download and put it here. And then I have this agent. This is the instruction. I will also show you how to write this elaborated prompt. This is the role, this is the purpose, this is the things it should do. Review, when I write start review, it should look for this folder, and then it should not hallucinate. It should provide the output in this format. Let's go and use that agent. So from here I can go and use PR review agent now. And then I can just say start review. As soon as I say this, it's going to get into all those review and it will create an output in this PR reports folder. So it is now going and reading all this and then trying to generate the report. I will show you the previously generated report meanwhile. So this is the report it has generated for the same project. And it can be Java project, Python project, .NET, anything. You can provide instructions accordingly and it will do the review. These agents can be also plugged into your pipelines. But then for that, they need programmatic access to LLMs. In companies, programmatic access to LLMs are not allowed at this moment. But in future, if they will be allowed, then you can build these agents and integrate into the pipeline stages. For now, you can use it in the CoPilot. So you see, it did a pull request review. It found security violations in these two files. Here it found this class and this method. The problem, it says passwords are stored in plain text in the database without encryption or hashing. This violates most basic principle of cryptography. Impact database can be compromised. Attackers can give unauthorized access, complete breach, and it is saying how to fix it. It's told add this dependency, then create another password config class, update your service class like this, and then you will be better. So it's not only giving a review comment, but also the code you should use to fix that. Same way it found another issue in this classes and it provided a problem, recommended fix, severity. It continues to do that for all others. Here it found a solid principle violation. Single responsibility principle got violated in this particular scenario. So severity is medium. So you can decide in your team that whenever a PR is raised and you run this agent, it gives a report. You share this report with the developer, and the developer should fix uh, the major or the high and medium ones. Low, you can still skip. You can decide that way. So let's say, how will you now provide this report? What is the report is generated and it's placed here. Again, you write a tool that and give the access to the tool to the agent in the agent's tool section, and then this will learn in future. Then that agent will, after getting the report, use that tool to push this report directly to the pull request review section, so that developer will automatically get the email. And once developer has fixed everything, you just run this agent again. It will download again the latest code for that whole repository or the PR, and then it will do the review. And if it finds any problem, it will again update the report. Otherwise, it will approve the PR. So no manual intervention in checking the pull request. Not even you have to go and tell the developer what should be the recommended fix. It is providing it automatically. And the way this does pull request review, a single human can never do that. Impossible to keep so many things in mind while doing pull request review. So as I'm saying, these tools, even if they are just 50% correct, they are better than humans by 200%. So please start embracing these tools and using them before it's too late. And now you see it is creating uh, another file. Of course, it will exactly provide the same thing because I haven't changed the code. So now the question is how I'm building these agents. So I will show you how to build these agents. Let's build one agent together. And this agent we will prepare for the documentation part. Now let's say I want to prepare documentation of my code base. So I have a PR review agent, I have an analytics agent, testing agent. Let's say there's legacy code and other things we want to understand. So first you have to basically go ahead and create here in the CoPilot. You go here and open. Oh wait, I have to save this. The new file which it has created, it will ask you to save. So it's very simple to create these agents because this doesn't have tool, so it's fine. So I'll keep this. I have to check now whether all my limit is exhausted or what. I think all my limits got exhausted for the agent or for the LLM. I think yes, it took away all the limits. Then I have to use login with uh, another let's say GitHub account. Then I will get tokens. But let me show you how to build this agent. So here you go and click on this new open chat, and here you will see settings icon. Either go from here and click custom agents, or here also you get if you click here configure custom agents. So what I will do is let me click here and say custom agents, and now create new custom agent, and then under GitHub agents so that it is applicable for all the projects in this workspace. You also can build cloud agents here. And here I will say, let's say document generator. If I have just typed document generator, hit enter, it will create an inside agents folder, it will create document hyphen generator dot agent MD file. If I save this and if I go here now, I will start to see that. So I can click here and it has nothing. What it has is just dummy text stating around what is agent and all those things. But then we want it to convert it to something which generates, which is a document generator agent. So let me share those with you how you can do that. I've kept it as an example. So for instructions, to create instructions file, you can use this as an example. For creating agents, you can use this. So in the agents file, I've kept certain text to tell CoPilot to create our agent MD file. So let's say for this one, this was the storytelling agent. I copy pasted this in the CoPilot and it created things for me. Same way for the senior software testing professional, I wrote what should be the role, what should be the purpose, input and output. Now let's say for the document generation, I will copy the PR review one, copy it, and I will paste it here. I will just modify it very simply. I will still say you are a full stack software professional, or I can say full stack software architect for professional architect with 20 years on writing high quality code in different technologies. Purpose: analyze the code provided in this folder. Yes, that's fine. And do the code review. No, generate the document. Generate the following documents slash diagrams. and then I will say what kind of. Flow, data flow diagram, then interaction diagram, sequence diagram, class diagram, ER diagram, and then maybe also code walkthrough. Whatever you want, you can continue to write and it will do that. If it is not doing that perfectly, you can fine tune the instruction again. After generating the artifacts, you can say the report should be created in the markdown format and return to a new folder under, let's say here I can say generated. I'm asking you to create a new folder in the root level, generated docs, and then the file name should be from the same. It should depend the timestamp. It should be in the following markdown file format and provided instruction. Input is same. User starts generating. I can say when the user types start generating, the agent should start to look into this folder and start generating all the artifacts. Do not hallucinate. And yeah, I think the document, all this not required here. You already specified. Must be simple to read and useful for beginners. Also use mermaid diagrams for creating diagrams. So mermaid is a library for creating diagrams. So I'm asking you to use that. And now what I will do is I will copy this. Once I've written this, I will go to this page here, but this time in the agent mode, and ask it update the document generation agent MD file according to the provided instructions. Here, and I will paste that what I have written. And now I will hit enter. Now it is going to use this, and then it is going to update our document agent file, this file. Let's see how it's updating. And once it has done that, so now it has created. I think it updated a wrong file. undo. We want it to update our agent file.
The input file is given wrong.
That's fine. If this is also fine, if we can supply to. Let's give this then. I think it updated this also, and it was trying to update that as well. So this is updated already. The document agent file is updated. So if I go here, and it was also putting it here. So sometimes it does this weird things, but it's fine. We can copy it, put it there. Ideally, it should have done kept it here. We'll copy this and paste it in our agent file. Done. And now we don't need this one. This created wrong. And as soon as now I go to my agent here, choose the document generation, and then I can say start. So it will, let's see if it is doing what we asked. It's going to Java folder, read all, and then it's starting to generate all these artifacts. But again, as I said, the code we have manually copy pasted, so we can write a tool to read this and put it here, the code first as a step one of the agent, and tell that agent to do that using that tool. Step two, review, analyze, review, and generate documents. Step three, push it to an artifact like a Confluence or a wiki page in your organization. Then the document is always there. And if you connect this to a pipeline, then it is always up to date with your code, the documents. So now it says processing, and it is trying to create a comprehensive report.
So there's not a specific format for the agent files for the instructions, right?
There is, it is like human understand. You first have to have, let's say, role, purpose, input, and output. Here is a better example. I think it removed all of it. Check. The loading. Now it's creating this. Let's wait. So there's a, you have to provide it in a specific format. And those format are not strict, but then the file should end with .agent.md. Only then you will see it here. And format is like instruction to human, like you give instruction, right? You are this person, this role, this is your task, this is your purpose. You should not deviate from this, and this is your input. This I am expecting as an output. Same kind of instruction you have to give this tools. Like here, the tester. Your name is tester. Your description is this. You're giving some hints. Later on, we will learn how to use tools. This is the role, purpose, and input, and then some restrictions and the output. So let's save this output and see the quality of report. So it created a folder generated docs. If I go and preview this now, so it is a Spring Boot project with REST API. This is how the flow works. This is the user interaction diagram, user registration flow is this. From user browser to this API call, and then controller register service. These are the DB queries on the data JPA, and then sending email, checking email, finally back to the flow. Then there is a property management interaction flow. There is a sequence diagram of user login, what calls, which field, class, what API, what function, what data inputs and output. This is the saving of the property, new property, because this is a Java project about, let's say, real estate property management. So saving the property, updating a property. This class diagram I could not render. Sometimes this plugin that we are using, right, it is not able to render few things. That's fine. But then there's the ER diagram it created. There's a user table, property table, address table, and code walkthrough. It is explaining the code now. This file has the starting code, and this controllers have this. These are the important annotation used here. Service layer has some important methods, explaining those methods, what they do. The data access, these are the models, address class, and finally, eventually, it will go and tell what are the things. This we haven't asked, but it's still told we have used certain things in a good way. So you can even combine the PR review and the document generation together, or you can keep it separate. You can also ask it to elaborate with more examples or more detail. You can give that your code walkthrough should be even elaborated, and you can give some examples how you expect. Same way, if you keep, you can also create agents around. You can basically keep many code base here and ask it to run on all top of all the code bases like microservices, and create even a bigger comprehensive project. Or each team can create their own documents, put it in a location, and build a big agent on top of that location that will analyze all those documents and create another big document. Or create a rack system, you can chat with those documents, and those documents are getting updated via the data pipeline from the code every day. So this was all about today's session of building agents in Copilot. These are quick wins. You can immediately go ahead and build them, and you can already be star in your projects, because people don't know to do these things also. That's pity, but then you can use this as your for your advantage. I will share this in a GitHub repository. Then what you have to do is just download that repository. Let's say if I share it like this as a GitHub repository, you don't know Git, that's fine. You just go and download a zip, extract that in a folder location, open that folder in Copilot, and then you will see this GitHub folder. As soon as you see this, then you can use this from here in your Copilot. You will start to see these agents. You will see agent, which is the custom agent of Copilot. You will see the ask, but here you will start to see your custom agents, and you can select the ones to do the perform different actions that we've been talking so far. Is it clear? Anyone has any questions? Hello?
Yeah, it's clear, Ranjan. So the
No,
initial
no questions, sir.
initial steps are clear actually. Yeah.
Okay, I will share the recording of the video. You all can watch it. So this session, in this week, we will not have any more class. We will have the class next weekend, so that you all get 1 week time to practice this in your company. If they are having doubts, questions, you can put it in the WhatsApp group, and then we can I can try to help if you're getting any error or issues. But then practice it first in your current local laptop, then go and practice in your organization with your organization code base, and of course after that you can tell your manager or show them that what you have built. Future, in the next weeks when we will learn about tools, then we will integrate tools so that you can integrate with your existing systems also. Then you're giving your agents more hands and legs also to do more things.
And have not heard suggestions on building agents from any one of you. So request you to share your thoughts on what are the agents that you would like to build, or if there are any thoughts that you have, and whether
Yeah,
that is
I've actually prepared some list.
Yeah.
I'll share it in WhatsApp.
sure, Priyansh. Yep.
Okay, I see Kingshuk has a question.
Yeah, go ahead, Kinshuk.
Yeah, right now I'm working in my company in which I got a, I guess, review checklist that is around 32 points in an Excel. So I am thinking to create an agent that will help to pass all those review requirements. So
Yeah,
are we can create like that something like from that MD file, giving those instructions, and all the instructions are all there in the that Excel file. So it will take because it will have lots of steps, and each and every application takes so much time to review all those things.
yes,
So better if it can assist me that agent itself.
yes. Yeah, I think see this is a good example. Like if you it's a repetitive task you have to do all the time, then you just create an agent and then use that agent yourself for doing those data pre-processing things and getting analytics out of it. And later on share this agent with your other colleagues so that they also get benefited. And then you can put it on your appraisal also that you build this thing, it helps many people.
Sure.
Okay. Are there more questions?
In that case, we'll wrap it up for today and meet you guys next week.
Yes.
Thank you, everyone. Thanks for your time.
Thanks everyone. Bye.
Thank you.